Hello, and welcome to the first video of our series called Vibration Diagnostics for Beginners. In this video, I will try to simply explain what vibration diagnostics is, how it works, and what it is good for. So, what is vibration diagnostics? It is a major part of condition monitoring programs. Over the years, vibration diagnostics has proven to be the most effective method for checking machinery health. Vibration diagnostics tools are here to help us to predict machine failures. When condition monitoring is applied and the machines are checked regularly, machine faults can be discovered at an early stage and appropriate action can be taken. By doing so, you can avoid unexpected machine shutdowns and you can avoid replacing parts which are still in good condition. How does it work? Running machines generate vibrations, which contain a lot of information about their condition. A vibration meter or analyzer is used to measure this vibration. The sensor needs to be mounted on an appropriate point on the machine, e.g. bearing housing. The instrument measures the vibration signal, tells you the severity of the vibrations, and also possible machine faults. The most frequent faults are bearing faults, unbalance, misalignment, and looseness. So, you've probably heard these terms before: predictive maintenance, machine condition monitoring, and also vibration diagnostics. What are these terms? Predictive maintenance. We can simplify the maintenance process as three different types. 1. Maintenance after failure. You simply use the machine as long as possible without any maintenance. It is the cheapest approach, but with the highest risk of unexpected shutdowns and the highest cost for repairing the machine. Imagine this situation. You install the new machine and switch it on. Then the planned factory downtime will come after a certain time. You do nothing with the machine. Then some failure will appear and the machine must be stopped. It takes some time to find and fix the cause of the failure, in the best case, and then repair the machine. The second type of maintenance is preventative maintenance. Repairs are done at predetermined intervals regardless of the actual condition. Here is a big problem with the repair frequency. You could repair the machine very frequently, and your unexpected shutdowns could be reduced to near zero. But your planned shutdowns and the costs would of course be enormous. On the other hand, very low repair frequency is a similar approach to maintenance after failure. Another disadvantage is that you are wasting your money because of the exchange parts which are okay. Imagine the same machine as before. After installation, you have to stop and repair the machine in planned intervals, over and over. And then some failure occurs anyway. Find and fix the cause, repair the machine. So what is the best repair frequency for your machines? The answer to this question is predictive maintenance. The machine should be repaired when it is really needed. The right moment is when failure is near, or in other words, when the fault starts affecting the machine but is still safe to keep the machine running until the time for repair suits the company best, for example, during a planned shutdown. And predictive maintenance can recognize this moment. Back to our example. After the machine installation, you take measurements, and the values are so large in this example. You can compare values with other similar machines, or use Adash or ISO limits. Something is wrong with the machine. Measured vibration data tells us that our problem is misalignment, probably caused by poor installation. Once the machine is repaired, the vibration values that were already measured are now well below the limit. After some time, the machine's unbalance will begin to appear slightly. We prepare balancing for the next factory downtime. You can see that only the predictive approach discovered the initial problem, and overall it is cheaper, more effective, and reliable. Another term is vibration diagnostics. So, to briefly explain what vibration diagnostics are. Rotating machines vibrate when running, and you can hear a sound, a noise, because noise is in fact vibration. When you speak, your vocal cords generate vibrations which are transmitted through the air to the other person's ear. You cannot see these vibrations, but you can hear them. Here is the bass speaker while playing some music. You can see the movement of the speaker membrane because the amplitude is high, but you cannot see the small movement of the machine while it is running. To see a motor's vibrations, we've got some excellent helpers today: an acceleration sensor and vibration meter or analyzer. Talking about the speaker again, can you separate each noise which comes from the speaker while playing some music? You can easily separate the bass, low frequencies, from treble or high frequencies with an equalizer. Why are we still talking about speakers? Because it is very similar to the vibrations on the machine. On the machine, we also want to separate these bass and treble noises, but here we are talking about separating machine faults, such as overall machine condition related to shaft speed, low frequency, and bearing or gearbox faults, higher frequency. To separate these faults, we use the vibration meters and analyzers mentioned before. While performing vibration diagnostics, we want to distinguish two important things which we get from the signal: overall machine condition and bearing condition, as each of them is diagnosed from different parts of the vibration signal. Vibration diagnostics is more sophisticated, of course, and later on you will find out that you need to separate more vibration sources which are generated by a running machine. For example, loose foundation bolts, unbalance, misalignment, fan blade faults, gear mesh faults, and many more. But for now, let's just talk about those two basic things for an easier explanation. The last term to clarify is machine condition monitoring. There are more methods for evaluating a machine's condition and its faults. Besides vibration diagnostics, you may have heard about ultrasonic detection, thermography, or other non-destructive testing. All of these methods are part of machine condition monitoring. Each method has its pros and cons. It is up to your maintenance program which methods you select or combine them, and which methods are the best for your particular machines. However, during the last few decades, it has been found and proven that vibration diagnostics is the most efficient and reliable method for most rotating machinery.